reaction that you won't be able to do at home.
And you said that's nitric acid.
Hydrochloric acid, but it's going to give you copper chloride, which is not going to be that beautiful blue. I'm going to cut off these lights so you can see the blue beautifully. This stuff is extremely, Myla, could you cut the backlight? And if any of you want to record it, please record it close so that you get a good audio.
Are we okay?
Okay, nothing is going to explode today. We'll do some explosions down the road. So here I have copper, here I have nitric acid. One of them will run out before the reaction stops to go further. So copper is solid, you can all tell. Copper is solid. And nitric acid is, it's not liquid because as I said in the very thing when I explained solid, liquids, and gases, this is dissolved in water. So that's nitric acid is extremely dangerous, extremely corrosive. If I put this, if it accidentally falls on my skin for the first few seconds, oh, nothing happens. After 10 seconds, you can see a hole in my hand. It's pretty bad stuff. Extremely dangerous, extremely corrosive. You won't be able to get this in stores. So I have solid copper. Most of the reactions, at least in this case, there's only 2 reactions. Let's say we have a reaction where we have like 4 reactants going to make 4 products. I mean, let's just assume that this is the case. Then not all of them equally contribute to where the reaction should stop. There's at least one person or one candidate in that A, B, C, D, or in this case, or copper and nitric acid. There's one that tells you, okay, that's it, we're done in the forward direction, we're done. So this is a beautiful reaction. It's not like the reaction is coming back, you will see. It's just whatever you make here, the product is reacting further to make another reaction. So this is a double header. So, I got my eye goggles, so it's okay. Hopefully nothing happens. And I go home in one piece. So I'll add concentrated nitric acid. This is not diluted. This is pure concentrated nitric acid. I'm going to put this in here and put this in a beaker of water. You'll see that you see that red fume? That's the copper reacting with the nitric acid. So what you see now is this red fume that you see, that's the NO2.
Oh, solid.
You see water is being sucked back now, right? Wait till, it's a beautiful reaction, but it's just so dangerous that, well, good things in life are dangerous. Or really risky.
Are we okay right here? I know, I'm like, is he getting ready to like blow?
It's building up.
Oh, man.
Look at the blue. It's a pretty color.
Oh, that's so cool.
Oh, wow.
Is that water or Clorox?
Water.
Smell.
Smell Clorox.
You see how we went through 2 reactions here. We started with just copper that looked copper. You all can tell. Now it's in. The copper and the nitric acid generated some gas. That was that sunset color red, right? It's a beautiful red color. This reaction is beautiful. The only problem is it's just dangerous. Not because it is going to explode in a sense, but the amount of heat, if you had touched it when it was red, it would felt really, really hot because it was fuming nitric acid. Like I said, if that went through my hands, probably put a giant hole or probably rip off all the tissues and skin here really, really quick. Okay, it gets to work like that. Okay, so it reacted with copper with I'm not going to write the reaction. If you're interested, you can Google it up. you make some product, say a major product, this product then reacts with water that's in the flask, and then it makes this makes a copper nitrate, I believe, so it makes copper nitrate, which is not so much color. It doesn't have any color. You saw that kind of brownish color on the bottom of the flask? That was the copper nitrate. And then when you add water, it becomes copper sulfate 5H2O. That's the spectacular blue color. It's not the reaction is going back to where it started, but it went here and it went back here. Now in this case, what do you guess would be limiting? I kind of started giving the answer. What do you think is limiting? In the first case, what would you guess would be limiting?
Copper.
Do you see any of that metal copper in there when it was first reacting? It's all gone, right? So it controls, we still have a ton of nitric acid. So if I keep adding more and more copper into it, but then I gotta wear goggles because at one point, this flask can't hold any heat. If any of you wanna hold this thing, you would just see how heavy this thing is. Just for the front row people, back row people can come and hold it. It's a solid piece of glass. It's made of Pyrex. It's really heavy. It's made of a really powerful glass. So it can withstand that much heat. Now if you do it with your regular glass tube, it probably would have shattered because of the heat that was here. So in this case, this was limiting because it tells, well, that's how much I can produce. All that gas went back here. Now I'm killing two birds in one shot. We're learning limiting because, and then you made this as one of the product, which again was in the flask. This flask started sucking air back in, and then when this ran out, we're done with the blue color too. So this is a sequence reaction. You went from here to here through an intermediate reaction where here this was limiting. What limiting is? Well, if you're not good at math, then that's a limiting factor in not doing math problems, right? If you're a horrible driver, then that's limiting towards you going at high speeds or taking chances with passing somebody. Like I have an aunt. She goes at 25 miles per hour on the freeway. It's ridiculous. No excuse. She should have been put in jail long back. She goes 25 miles per hour on the highway. That is just no excuse. Okay, now that's because her limiting factor is her fear that she will crash into somebody, hit somebody. So in this case, the copper, solid copper metal was limiting, and then it made copper nitrate. Now copper nitrate was at the bottom of the flask, and then you had all that hot gas on the top. When the hot gas cools down, the water is sucked back in, and it made this. This is limiting now because there's only so much of it was on the bottom of the flask. The rest of it was all nitric acid and the orange gas, the reddish gas that you can't see. So most chemical reactions, we're going to cover two kinds today, which is around which all our problems will be focused. And you got this beautiful blue color. Now it's safe to touch, no danger. It was just when the danger was not when it was generating gas, but it was when it sucking back the water in. Because you don't add acid to water, you add water to acid. This was pure acid in it. There's still a lot of unreacted nitric acid because we said copper is limiting, so we had a lot of unreacted nitric acid. And when that goes back in, it's going to splash and generate this instant heat. That's why I'm doing it in this giant flask. If I do it in a small flask, I probably would have all told you to move 10, 15 feet away, and then I would probably be there wearing glasses, face mask, because it would shatter that into pieces. It's that powerful reaction. Okay? So like I said, beautiful things are difficult to come in life. You gotta take your chance, and I took my chance to do this because this is normally done in a hood. This is not done in a classroom setting. This is probably one of the finest demonstrations I have done, to be honest, because I took my chance with it. If Tony's eyes get lost,
Really?
Just kidding. That's not, I wouldn't do it that far. If I know there was that much risk involved, I probably wouldn't have done that. So, anyway, so we're gonna learn two types of reactions. Most chemical reactions have limiting factor, most of them don't. And I was gonna do something else today, but again, they didn't have a face mask, so I didn't wanna really do that one. But this is relatively safe. But again, the problem was, now, let me